Okay, we're going to talk about different forms of energy today and how these different forms of energy can be transferred from one form to another. It's actually pretty interesting stuff. I hope that you have your Chapter 7 guided notes out. Please be following along and write this stuff down. And hopefully we'll learn something today. Okay, so there's a whole bunch of different kinds of energy. So I'm just going to go through and list them here. I think you're supposed to write them. But let me talk about them as you're writing them down. So it says here that energy can be transferred into many different forms. So energy transformations, that's what we're talking about today. Well, let's talk about all the different kinds of energy first. There's solar. In fact, all of the energy on Earth comes from the sun. So that light energy from the sun, we call it solar energy. Nuclear energy. This comes from the nucleus of atoms. And since everything's made up of atoms, almost everything, we're going to talk about the nucleus and how it gives off energy today. There's just a tremendous amount of energy in the nucleus of atoms. All right, number 3 is electrical energy. So moving electrons or electricity. We'll talk about electrical potential energy. We use that every day. Number 4 is chemical. So in molecules, there's atoms. And in between the atoms in a molecule, there's chemical bonds. And in those bonds is stored energy. We'll talk a lot about chemical energy today. Sound. Whenever you hear something, you're hearing sound energy, the compression of the air molecules in the air. And it reaches your ear, and your eardrum interprets that into a sound. Number 6 is kinetic. We talked a lot about kinetic energy in the last video, or last lesson. This is moving. Okay, we calculate kinetic energy by taking 1/2 the mass times the velocity of the object squared. So this is the moving energy. So if it's got mass and it's got some velocity, it's going to have kinetic energy. We also talked a lot about this one in the previous lesson. Gravitational potential energy, which we just called potential energy, is equal to mgh. So as long as the substance has mass and it's at a height above the floor or the ground, it's going to have gravitational potential energy. There's also elastic potential energy. This is where you change the shape of the object like a rubber band. You stretch it out, you're giving it elastic potential energy because it wants to spring back into its rest position. Okay, number 9 is thermal energy. Thermal means heat. We'll talk a lot about heat energy. Number 10 is wind. We're familiar with that. I wanted to focus right now on mechanical. Okay, mechanical energy. Actually, what mechanical energy is, so mechanical energy is equal to potential energy plus kinetic energy. So it's energy due to the position that the object's in, plus it could be moving as well. So if it's got potential and kinetic, we call it mechanical energy. We're going to explain that today. And then finally, light energy. Okay, so finally we'll talk about light energy. And this doesn't have to be from the sun. We can actually get energy from light that's not the sun. So we'll talk about that. Let's go in and explain a few of these in more detail. The first one that I would like to talk about is elastic potential energy. Elastic potential energy is the energy stored in an object when you change its shape. Examples of this is a rubber band. You stretch it out. It wants to spring back into its rest position. So there's potential energy there because you changed its shape. You also see this with springs. An archery bow. If you look down here, if this guy pulls back the string, it's changing the shape of the bow, which is giving it elastic potential energy. If he was to let go of this string, the bow wants to spring back into its rest position, which will transfer that energy into the arrow. Pole vaulting. You see this all the time. The pole vault has elastic potential energy look at how much he's changed the shape of the pole vault. Well, this potential energy, because of the change in shape, is called elastic potential energy, is going to hopefully propel him over the bar here. And so you see elastic potential energy in a lot of different things. Okay, I wanted to talk about the potential energy stored in a spring for a second. So there's an equation for the potential energy of elastic substances, and it's right here. So elastic potential energy is equal to 1/2 k times x squared. Let me talk about this for a second, guys. So if you wanted to find the potential energy in a spring, say for example this spring, well, we're going to take 1/2 k. K is the spring constant. Based on how difficult it is to compress it or to stretch a spring out, it's got a spring constant. We take that and we times it by x, which is how far you have moved the spring, and you can find its potential energy by taking 1/2 the spring constant times the distance that you move the spring squared. And so springs, again, are just a form of elastic potential energy. Okay, this one is in your notes. It's very important. Chemical potential energy is the energy stored in the bonds between atoms in molecules. So it's stored energy in the bonds between atoms in a molecule. So I've got a huge molecule down here, palmitic acid. Look at all the different bonds here, these bonds between different atoms. So this line right here represents a chemical bond. Well, there's a lot of energy stored in those bonds. Examples of things that have chemical potential energy is food. That's how we get all of our energy, is breaking chemical bonds from food. Fossil fuels, huge energy source. In fact, most of the energy produced by us here on Earth still is from fossil fuels. Burning of coal and oil, gasoline. It produces a lot of energy from fossil fuels, and we're breaking the chemical bonds that exist in those things. Plants, they're made up of molecules, and we can get a lot of energy from plants through the chemical bonds that exist there. So this is an equation. This is a chemical equation for cellular respiration. This is how all animals get energy. Those things that don't get energy from the sun and do photosynthesis, they get it this way. We get our energy from cellular respiration. So when we eat food, our metabolism breaks it down, our digestive system breaks that food down into a simple form right here called glucose. Well, we breathe oxygen because that oxygen helps us break up this glucose into CO2 and water. But most importantly, it gives us energy. So how that works is you have a bunch of food, has a bunch of glucose. It goes into our cells, our mitochondria harvest that energy from us. And this products here, CO2 that you're exhaling in water, they don't have very much energy. So there's an energy difference here. Can you just destroy energy, guys? No, you can't destroy energy. Where does it go? Well, it leaves. And we make, in our bodies, ATP out of that energy. It produces heat. That's why our bodies are at a higher temperature than room temperature. And so we use the chemical bonds in food to get energy. Here's another example of using chemical potential energy. Here's a picture of a stove or a furnace maybe. They're burning methane. Methane is natural gas. Methane is a molecule that looks like this. If you were to draw its structure, it's got two atoms, carbon and hydrogen. It's got 4 chemical bonds between the hydrogens and the carbon. Well, what happens, let's say this methane right here is going into your furnace and you're at your house. Your furnace is going to react it with oxygen. Combustion reactions have to have oxygen. But when you burn it, all of these bonds are broken right here. These chemical bonds get broke. And so all the atoms are now individual placed, and they're by themselves. They don't have bonds for a split second. So you break those bonds, Now, when the products form, the products of combustion of methane are CO2 and water. When they form, they reform these chemical bonds, but they're at a lower energy. So the other energy is converted to heat. So it releases a lot of heat. And that heat we use to heat our houses with. And that's how your furnace works. So, anyway, a lot of energy in chemical bonds. It's a very common form of energy. Okay, let's move on. Electrical potential energy is the potential energy of electric charges or groups of charges that are held at a distance from each other. When I think of electrical potential energy, I just think of electricity and moving electrons. But there's more than that. You could have a proton and an electron. Is there an attractive force here? Yeah, they're attracted to each other. Or you could have two electrons, which are going to repel each other. There's electrical potential energy there. A battery stores a bunch of electrons on the negative terminal. When you put it in your device, that stored energy, the stored electrical potential energy, is released in the flow of electrons here, so electricity, and the electrons move to the other side of the battery. Produces some form of electric energy. Okay. Nuclear potential energy. This one's kind of interesting, so let's talk about that. Nuclear potential energy is the potential energy stored in the nucleus of atoms. Okay? The protons in the nucleus want to repel each other. What charge do protons have, guys? Positive. They're positive. Do protons like to be by each other? No, they like charges want to repel. Well, if you get large atoms, like look at the periodic table right here. How many protons are in uranium? There's 92. And so this uranium atom right here, this uranium nucleus, has 92 protons in there that don't want to be by each other. So when you have large atoms, you have a lot of protons in the nucleus, and they don't want to be by each other, so what it does is it makes that nucleus want to fall apart. Well, when the nucleus wants to fall apart, we say it's radioactive. Because when it falls apart, it releases radiation. Okay, and so when this uranium atom is hit with a neutron, this is how we split atoms. We'll shoot it with a neutron, and it will split this atom into two smaller atoms. So uranium gets split into cesium and rubidium down here. When you split an atom, though, it releases a lot of energy. So there's a lot of energy stored in the nucleus. This is called a nuclear reaction. What kind of nuclear reaction is it when you split an atom? This is called nuclear fission. This is how nuclear power plants get their energy to heat up the water. They're splitting atoms and it releases energy. Well, there's another kind of nuclear reaction. What is this one? When you have two atoms, two small ones, and you bring them close together and they hit each other and they combine. This is called fusion. You see fusion with smaller elements. Hydrogen is our smallest element on the periodic table. How many protons does it have? It has one. So if you take one proton and slam them together, you're going to make an element that has how many protons? 2 protons. What element is that? That's helium. This is the exact nuclear reaction that's happening on the surface of the sun right now. It's taking hydrogen, slamming them together, and making helium. Well, when you do that, it releases a lot of energy. Okay? Even more than fission. A lot more than fission. So there's a lot of energy in the nucleus of atoms. And actually that's what Einstein figured out, is how to tell how much energy can be released by doing these reactions. E equals mc squared stands for energy is equal to the mass defect times the speed of light squared. Speed of light is a huge number, and when you square it, it's just even bigger. So you times it by the mass defect, and so that's why the energy is so big. You're squaring the speed of light here. And that's what tells us how much energy there are. Okay, energy transfers. For the rest of this lesson, we're going to talk about how energy can be transferred from one form to another. This gets a little bit tricky, but I think we'll catch on. You'll get the hang of it and it should be pretty easy by the time we're done. So let's go through it. It says another definition for work is the transfer of energy. Energy can be transferred from one form to another. There's this thing in science, this very important law called the law of conservation of energy, which states that energy can't be created, nor can it be destroyed, but you can change forms. It can be transferred into another kind of energy. Like we were talking about earlier with the boulder on the side of a hill. If it's just sitting there, what kind of energy does it have? Potential energy. Well, if you push that off the hill, it's going to transfer that energy to what? To kinetic energy. So energy can't be created, nor can it be destroyed, but it can change forms. When energy is transferred from one kind to another, no energy is lost. You can't destroy it. And no energy is used up. You can't create or destroy energy. So we've got to track where the energy is going. And that can be a little bit tricky. So here we go. I wanted to start by talking about this slide. This is the big picture here. Okay? So let's talk about energy transformations that's happening here. Well, the universe, all of the energy in the universe started with what event? The Big Bang. Okay? So it says here the Big Bang starts nuclear reactions in the sun. So after the Big Bang, a bunch of hydrogen in the universe came together because of gravity, made stars. Our sun is a star, and it's burning by nuclear reactions. Okay? So nuclear reactions in the sun cause the atoms to release heat, light, and other electromagnetic energy. So we have hydrogen being fused with hydrogen, and it makes helium. Well, that releases a lot of heat energy and light energy. Well, the light from the sun and the heat from the sun come, and it hits this plant. What do we call that? Photosynthesis. Well, in photosynthesis, we're taking light and heat energy from the sun, and we're converting it to what? What's the energy transformation that's happening here? So we're taking light from the sun and making what out of it? What does it make? Sugars, right? Glucose. So it's making chemical energy. Chemicals that it uses to make the plant. Well, then this duck eats this plant. So it's taking the chemical energy in the plant, and it's making chemical energy in its body. It's what makes up its body, is how it grows. And so it's using it to make chemical energy in the chicken, or the duck here. Well, who eats the animals? We do. So we're taking that chemical energy in the animal, and we're using it to make chemical energy in our bodies. But do we just use it to make chemical energy? Oh, we can use it to make kinetic energy, riding this bike up the hill. And if we're at the top of the hill, we have a lot of what kind of energy? Potential energy. And then you can use that potential energy to ride down the hill and make kinetic energy again. So notice how these energy transformations just keep going. It's a big cycle. We're just cycling the energy that's already here in our universe into different forms. Okay, so here's some simple examples of energy transformation. We can take light energy and create it, and a plant makes what kind of energy? Chemical. What is this process called, guys? Photosynthesis. Good. Or here's what we do. We eat food, so we get the chemical energy in the food, these chemical bonds, and we can make mechanical energy, which is moving, and potential energy. And so this is called cellular respiration. Okay? What about if you have to plug in your hot plate here, and you're going to heat up this water? Well, we're taking electrical energy from moving electrons, and we're causing thermal energy to heat up that pot. So there's an energy transformation. This one down here, when you fill up your car with gasoline, the gasoline has chemical energy in it. Your car uses that chemical energy to ultimately move it. We call it mechanical energy. Since we live right by a coal power plant, since it's called IPP, Let's talk, I know we started the chapter with this, but let's talk about the energy transformations that's happening with IPP. What are we starting with? What do you have to haul into IPP every day? Coal. What kind of energy here? Chemical. Isn't there chemical bonds in the coal that we're going to harvest? So this is chemical. Okay? Well, what do we have to do to that coal? You have to burn it. So what kind of energy is this? Thermal or heat energy. That heat energy does what? Heats up the water, which causes it to go to steam. And the steam does what? It turns the turbine, or the electric generator. So that spinning motion, we could actually say that's mechanical, or kinetic energy, right? It's moving, it's mechanical. And that mechanical energy is going to be converted into what kind of energy? Electrical energy. And then we send that electrical energy down the power lines here. And when it gets to your house, you can convert it into what kind of energy? You can convert it into light energy, right? Or whatever appliance you have at the end of your electrical line there. All right, let's see if we got that right. So chemical energy from the coal goes to thermal energy when we burn it, to mechanical. Again, guys, I want to talk about this. Mechanical, basically when something is moving and it's got potential energy at the same time, we say it's mechanical. So the spinning of the turbine is mechanical, and then we make electrical energy from it. So good job. Okay, now we're just going to finish this lesson off with a bunch of practice problems. Whoa. So practice problem 16. What is it, guys? What is this picture of? Solar panels. I want you to explain the energy transformations that are occurring with solar panels. What is it? What are we starting with? Solar, which is light from the sun, is being converted into what? Into what? Electrical. Electrical energy. So we're taking energy from the sun, the light energy from the sun, and converting it into electrical energy. That's what solar panels do. Okay, very good. Let's go to 17. What is this, guys? It's a windmill. Let's explain the energy transformations happening here. What are we starting with, obviously? Wind. Okay. Wind energy is being converted into what? Mechanical. Yeah, that spinning of the turbine. Okay. The spinning of the electric generator. And then that spinning, the mechanical is being converted into what? Electrical. Electrical. Okay. You can even get more precise and be more specific, but let's just stay general. It's going from wind to mechanical to electrical. Okay, number 18. What's happening here? Okay, so we're starting with, in order for the flashlight to work, you've got to have what in it? Batteries. What kind of energy do batteries have? Chemical. Chemical. And what are we converting it to?
Is it an LED?
Yeah, see, you can make it very specific. You can make it very specific, but let's just say general. Okay, so it's taking the chemical energy in the batteries and converting it into what? Electrical, and that electrical energy is converting into what? Light energy. Into light. And so that's how the battery or the flashlight works. So chemical to electrical to light. Let's try another one. Okay, this car. Let's describe all the chemical, the energy transformations that have to go into making your car move. Okay? So what do you need first?
Gas.
Some gas. What do we call that energy in gasoline? Chemical. Chemical. and then it goes into, the gasoline goes into the engine where the spark plug will do what? Ignite it, and it turns into heat energy or thermal energy. Okay? And that thermal energy, that explosion inside the cylinder, causes the piston to move, right? So what do we call that moving energy? Mechanical. And that mechanical energy, I guess, is what, the moving of the piston up and down is connected to the drive shaft, which is connected to the wheels, which turns the wheels, right? So that's how the car is moving. Correct?
Correct.
Yeah. All right, here's an interesting one. Practice problem 20. Let's say that these are speakers that you plug into the wall. So they've got a wire coming out, and it goes into this plug here into the wall. Okay. So what's happening?
Electrical.
So yeah, we're starting with electrical energy. And we're converting that electrical energy that's coming through this wire here to what?
Sound. Electrical energy.
Does it just go to sound all in one step? So what happens here is the electrical signal is converted, and it's making this diaphragm of this speaker move back and forth, right? So the moving of that, you could either say, well, let's just call it mechanical.
Elastic.
Yeah, I was going to say you could call it elastic because it does move back and forth, but I think mechanical is probably a better term. Yeah. Okay, so that moving of this diaphragm right here causes what kind of energy? Sound. What that does, guys, is it compresses the air around it, and so you can make sound waves, and then sound waves go to your ear. It's your eardrum, which again moves back and forth. The bones that are connected there are connected to nerves, which goes to your brain, and you interpret that as sound. Anyway, electrical to mechanical to sound. We good? Speakers. So now what if it wasn't the kind that you put in the wall? What if they were portable speakers that you had batteries? How would this change? Yeah, this would be chemical to electrical to mechanical to sound. So you just add another one there before it's chemical. All right, 21. A microphone. Okay, so where does it start? Well, in order for a microphone to work, you have to speak into it, right? So what kind of energy there? Sound, right? Sound. So when you talk into it, all these compressed air molecules are going to hit the microphone. Inside the microphone, there's a little diaphragm again that moves back and forth when the sound waves hit it. So what do we call that? Mechanical. So that's the moving of this diaphragm back and forth. We'll just call that mechanical. And then that diaphragm moving back and forth, that energy is converted into what kind of energy, guys? Yeah, the electrical energy, which is moving down this wire, right? So electrical.
Bless you.
Okay. So what do you notice about a mic and a speaker? How are they related? It's reversed.
So the speaker takes the electrical and captures.
Yeah. And the only reason you have a mic is to connect it to a speaker. So if this electrical energy right here is coming down this wire, it's going to go to a speaker, which is going to convert that electrical energy into mechanical and then into sound. So, kind of interesting. Okay, we're almost done. We're almost there, guys. Practice problem 22. This is a pizza. What should we say?
Stuffed crust. Ooh, I love stuffed crust pizza. Man, that's like
What kind of energy is there, though?
happiness. It give me energy to do anything.
How do we get energy from food? Chemical. Chemical. And
To my mouth.
then what do we do? Yeah, I would say thermal, because it goes into our bodies and our mitochondria, and we break those chemical bonds, and it releases heat. So let's put thermal. In fact, that's how you maintain your body temperature of 98.6 degrees. Okay? But it's not just thermal. Can we go to some other kind of energy? Mechanical or mechanical. That's a good one. Yeah, moving, right? It helps us move. It helps us move around and talk and think and do all these things. So we're getting our energy from chemical bonds in food. Okay, I've got just a couple more, I think. 2 more. Okay, you guys try this one. So if you're watching the video, please hit pause. Try this one. See if you can get this one right on your own. Okay, let's see how you guys did. This is obviously a nuclear power plant. So what are we starting with? Nuclear. That nuclear potential energy is being converted into what kind of energy? Thermal, yeah. We're using those nuclear reactions, that's fission reactions, to heat up the water. So let's say thermal. Okay, so it heats up the water. The water turns to steam, which does what? Which turns the electric generator, so mechanical. And that spinning of the generator does what? Converts it to electrical. So there's actually 4 there. So nuclear to thermal to mechanical to electrical. Very good. Okay, last one. You guys tell me the energy transformations that are involved here. Okay, let's just do this one together. So you're on this splash mountain and it's at the top. What kind of energy is at the top? Potential. But it is still moving. So should we say what? Mechanical. Yeah. Because and now it is potential, but it's still moving. So let's put mechanical. So that mechanical energy is being converted into what as it moves down? Kinetic.
Oh, I get it.
Kinetic. And you can get you can go as precise as you want to with this stuff. Would there be also friction and heat and thermal because of the roller coaster and the track? Yeah, but basically what's happening is you're taking potential energy here and converting it into kinetic energy down there. Okay, before I finish, let's see if you guys learned something. So here's my word bank. Here's my word bank down here. You guys tell me what to put in. This is an alarm clock. Okay? So what are we starting with? Electrical. And it's using electrical and doing what?
Changing it to...
Now, if we can only use one, what would you put down there? Probably sound. Yeah, it's got some buzzer or some music that comes on. Okay. This is a bell that this guy is moving back and forth. He's got to move his hand back and forth and the bell sounds. So what are we going to put here? Kinetic to sound. Okay, I like that one. Okay, this is a candle. It's got some, it's an oil, kerosene or something here, and a match here. So what are we going to put? In order to burn a candle, what do you have to have?
Candle.
I would say you got to start with chemical. Don't you have to have some chemical bonds here in the match and in the candle here itself? And we're taking that chemical energy and you do what to it?
Turn it into thermal light.
Is there heat and light? Yeah, heat and light energy. Okay, good. Now, what this picture is, guys, is it's a solar panel. Okay, so what are we doing here? Yeah, actually, you don't have to get light from solar, from the sun. You can actually produce electricity from light. So let's just put light here. So light hits this, and what does it turn it into? Electrical.
Electrical energy.
Okay. Okay, that's it. Guys, hopefully you understand energy transformations. Let me finish up by asking you a couple questions. Can energy be created?
No.
No, it's been here since what event?
The Big
The
Bang.
Big Bang. Can we destroy energy?
No.
Can't destroy energy. So, can energy be converted from one form to another, though?
Yes.
It can. And hopefully we have learned enough about this to understand how energy is converted from one form to another. Now, to give you some more practice, in your student workbook, there's a worksheet titled Energy Transformation Worksheet. So please go there. Again, it's called Energy Transformation Worksheet. Let's get that done, and hopefully this video helped.